All right, so we are going to work on our Exam 3 review for business math. So we've got some probabilities going on in here. We have some standard deviations, and then we're going to solve some systems of equations and using corner points and such. So let's get started. All right, so the first one, we have several things happening here. We have A through F. This is about probability. So our first question is, if the probability that your television breaks before the extended warranty is 0.015, what is the probability that the television will not break? So in this case, we have to remember that all probabilities add up to be 1. Okay, I need to adjust this so I can write. So all probabilities total up of the events in a situation equal to 1. So for example 1, part A, we will have 1 minus the probability of the warranty breaks. So the probability that it won't break will be 0.985. So you just subtract that amount from 1. All right. Part B says there's a 1 in 5 chance that it will be sunny this weekend. What is the probability that it won't be sunny? So for part B, we're still subtracting it from 1. And 1 out of 5 would be 1 out of 5. And we can change that to be 5 out of 5 minus 1 out of 5, which will get us 4 out of 5. If I give you one like this, I would expect that you leave it as a fraction. I don't want a decimal answer for this. All right, part C. If we assume that A and B are events, if probability of A equals 0.4, probability of B equals 0.55, and the intersection, the probability of the intersection is 0.25, we need to find the probability of A union with B. So there's a formula that goes with this that says that if we have the probability of the union, it is equal to the probability of each of the parts, in this case A and B, minus the probability of the intersection of the two events. Because when we're talking about union, it's going to be all of this and all of this, but sometimes they overlap. So you have to subtract the overlap part, otherwise it gets counted twice. All right, so in this case, the probability of the union of A and B, probability of A is 0.40, probability of B is 0.55, and the intersection is 0.25. And when we do the math, we get 0.70. All right, part D. Part D says a card is drawn from a well-shuffled deck of cards. Find the probability that the card is a club or a 6. So this is similar to the one that we just did. The probability of a club, that the card is a club or a 6. So when it's an or, it is a union. So we would need the probability of a club plus the probability of a 6 minus the probability of a club intersected with a 6. So the probability of a club union with a 6 is going to be the probability of clubs. So this is where these are things you have to know. There's 52 cards in a deck, and there are 4 suits. There's hearts, clubs, diamonds, and spades. And each of those suits has 13 cards. And if you don't remember that, if you can remember the 52 cards, divided by 4 suits will get you 13 as well. And then for each specific card, like a 6, a 4, a 10, a king, a queen, there are 4 of each of those, because there's a 6 of clubs, a 6 of spades, a 6 of hearts, and a 6 of diamonds. Or there's a 10 of clubs, a 10 of hearts, a 10 of spades, a 10 of diamonds, whichever. So keep in mind that that's going to be, there's 4 of them. And then there's only one 6 of clubs. So this would be 13 clubs out of 52 cards, plus there are 4 sixes out of the 52 cards, but there is only one 6 of clubs out of 52 cards. And we're not going to reduce these yet because we have a common denominator here. So 13 plus 4 will get us 17 minus 1. We'll get a 16 out of 52. Now we'll reduce it. They both reduce by 4, so 4 out of 13 would be our final answer. All right, our next example says that an experiment consists of rolling 2 fair dice and adding the dots on the 2 sides that face up. Assuming each simple event is likely as any other, find the probability that the sum of dots is 7. So when they talk about just rolling 2 dice and they don't specify anything, then they are talking about the fact, sorry, this is not, I was thinking we're on example 2. We are not. We are on E. I'm so sorry. We are talking about that they are 2 6-sided dice. If it doesn't say it's 6-sided dice. If it does say, then it'll say like 2 fair 8-sided dice or 2 fair 9-sided dice. It will actually state that. But if it doesn't, then we're assuming that it is a 6-sided dice. Now we have 2 of these, and as we're rolling these 2 dice, we have to think about what the total is that we're looking for. And how much is available on each of our 6-sided dice. So, sorry, I'm going to be a little noisy here. I realized, let's talk about these dice. So I have 2 dice here. There are 6 sides on each. And I'm trying to come up with a total, it said, where the sum of the dots is 7. So I'm thinking about how I can equal to 7. If I start with a 1 and a 6, that's a way to get to 7. So I'm going to start listing the possibilities. I have a 1 and a 6. And then if I take a 2 and a 5, that will equal 7. And then I could get a 3 and a 4. That will get me 7. And then if I got a 4 on the red one and a 3 on the blue one, that would get me 4 and a 3. And then if I get a 5 here and a 2 here, that will also get me a 7. And then I could get a 6 on the red one and a 1 on the blue one. So that makes me a total of 7 right there on each of them. So you don't need a set of dice. What you can do is say, well, if I start with a 1, 1 plus 6 is 7. If I then rolled a 2 plus 5 is 7. A 3 plus 4 would be 7. A 4 plus 3 would be 7. A 5 plus 2, so you can go backwards. The only time you don't repeat is if, let's say we were doing 8. If I roll a 4 on that's the same number on them, you don't repeat it and say, well, it was this way and then it's this way. Those don't repeat. But all the other ones, getting a 4 on the red one is different, and a 3 here is not the same thing as getting a 4 on the blue and a 3. These are two different rolls here because of which dice is getting the number. So just be aware of that. You'll just kind of go up and then come back down. So how many total do we have in our event? Because we haven't found the probability. We just found what the possibilities are. So we have 1, 2, 3, 4, 5, 6 options that give us 7 out of the total. Now, you have to remember how many total possibilities are there for the outcomes of rolling 2 dice. And we've learned this before, and we have it's in your handout where it's all mapped out. But basically, it's the fundamental counting principle. I have 6 sides on this one. I have 6 sides on that one. 6 times 6 will get you 36. That's the total possibilities of the outcomes you could get. And of course, you need to reduce this down. They both divide by 6, so 1 out of 6. All right, our next option, or next question for letter F is, I'm going to scooch back down here. An event consists of rolling 2 fair dice and adding the dots on the 2 sides facing up. Assume each simple event is likely as any other. Find the probability. Sorry, that was my alarm. Find the probability that the sum of the dots is less than 6. So now we're not making a total of 6. We need all of the less than 6. So that means they can't total 1, because if I'm using 2 dice, the smallest total is 2. So 2, 3, 4, and 5. So I'm going to do this list a little bit more organized. So I'm going to start with 1, and 1 would get me 2. A 1 and a 2 will get me 3. A 1 and a 3 would add up to 4. A 1 and a 4 will get me a sum of 5. I can't go 1 and 5 because that will get me a 6, and it has to be less than 6. All right, now, if I start with a 2, I can do a 1. I can do a 2 and a 2. And I can do 2 and 3. That'll get me a 3, a 4, and a 5. I can't do 2 and 4 because that would get me 6. So now let's say the first one is a 3, the second dice is a 1, that's 4, and a 3 and a 2, that would get me 5, so I can't do 3 and 3 because that'll get me a 6. And then I could do a 4 and a 1, that totals 5, but a 4 and a 2 would make it 6. So how many options do I have this time? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my probability is 10 out of a total of 36, which will reduce down to 5 out of 18. Okay, so that is our probability parts. Let's go look at the different types of events that we're looking at. All right, so let's go look at number 2. A store carries 4 brands of televisions, S, J, R, and M. From past records, the manager found that the relative frequency of brand choice among customers varied. Would the following probability assignments for a particular customer choosing a particular brand of television be rejected or accepted, and why? So we are given all of the probabilities here, so all we're going to do on these is add. This chart here goes with our next problem. So we just need to add these and then decide if it's going to be accepted or rejected. So let's add up our values here. So for example 2, for the A option, we're going to add all of our values. We have 0.29 plus negative 0.14 plus 0.37 plus 0.48. It equals to 1. Now remember, our probabilities on an event should all total to be 1, but we're going to discuss whether they're accepted or rejected in a minute. 0.17 plus 0.32 plus 0.26 plus 0.25 gets us 1 again. And C, we have 0.63 plus 0.23 plus 0.18 plus 0.29 gets us 1.33. Now I just reminded you that all of our probabilities would add up to be 1. Well, this one is greater than 1, so this one's automatically rejected because it equals something that is greater than 1. So that is rejected for the greater than 1. So the total greater than 1. All right, these two both add up to 1. But remember, our probabilities aren't negative. They are all positive numbers. The probability of each item is between 0 and 1. That's one of the understandings that we have. We can have a probability of 0, we can have a probability of 1, and anything in between, but we can't have a negative probability. So this one will be rejected because we have a negative probability. And that's the second term right there. And then this one, it equals to 1, which is a good thing, and I see no negative probabilities, so this one would be the only one to be accepted, would be B. Okay? All right, let's go look at example 3. We're going to find the probability by referring to the tree diagram and using Bayes' formula. We are looking at the probability of C, that line means given, that R, its complement is what it means, R complement, occurred. So C, given that R complement occurred. So if we're looking over here, we're looking at C, given that R complement occurred. So that means we've got the two probabilities here. Now that was what we'll put on the top, and they'll be multiplied. But on the bottom, because we're given that R complement occurred, we have to look at all of the complements as they occur. So we will put on the bottom the C in R complement, the B to R complement, and the A with R complement. So look at example 3. So the probability of C, given that R complement occurred, will be 0.25 times 0.9 on the top of our fraction. All right. And on the bottom, we will have our 0.25 times our 0.9 plus 0.2 times 0.9 plus 0.55 times 0.8. Now that I've shown you the numbers, let's go look at, again, y. So 0.25 times 0.9 is the part we're looking for. And then we have to put the denominator as this one, and then 0.2 and 0.9, and 0.55 and 0.8. So we're only looking at the R complements, we're not looking at the R's. All right, now we just have to do some math. So on the top, we will get 0.225, and on the bottom, we have 0.225 plus 0.18 plus 0.44. And I'm writing this out so that I make sure, if I need to double check my math, I've got my numbers there. And it's good to show your work. So we have 0.225. When I add these together, I get 0.845 is equal to 0.266. So that's our probability of C, given that the R complement occurred. All right, let's go look at example 4. So for example 4, a tire manufacturer produces 80% of its tires at plant A. If 6% of the tires manufactured at plant A are at plants have defective tread, what is the probability that one of this manufacturer's tires was manufactured at plant A and has the defective tread? So we're looking at 80% of them were made at plant A, and 60% or 6% have at one of the plants has a defective tread. So the probability that plant A has a defective tread, well, we have to go just do a simple multiplication here. So this will be example 4. So it's 80%. We have to change that to a decimal. And we have 6%. And we need to change that to a decimal. So we have 0.80 times 0.06 will get us 0.048. And that's the probability that a defective tire would occur at plant A. All right, example 5, we need to find the median and the mode for the following distribution. So first thing I have to do with this is I have to put it in numerical order. So let's go put our numbers in numerical order. So numerically, they will be 3, 5, 5, 6, 7, 8, and 9. Now I don't have to do this to find the mode, but I need to do this in order to find the median, the middle number. So I have 1, 2, 3, 4, 5, 6, 7 numbers. Always double check that what you wrote down are 7 because you had 7. 1, 2, 3, 4, 5, 6, 7. I've seen easy mistakes because students didn't write the entire set of numbers down. All right, so that means we're going to go into the middle. 1, 2, 3. Middle number is going to be 6. So our median equals 6. And then for the mode, remember the mode is the one that occurs the most. And 5 is the number that occurs the most. So that would be our answer. All right, number 6. We need to find the mean and the standard deviation for the following. So remember that the mean is x bar. So when we're looking at finding the mean, that means we have to add all the numbers up and divide by the number of numbers we have. So we're going to do 2 plus 12 plus 3 plus 11 plus 14 plus 5 plus 8 plus 9. And again, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. I didn't leave a number out. That also tells me I'm dividing by 8. When I get the total on the top part, the total is 64. Divided by 8 gets me 8. So there's my mean. Now, for my standard deviation, I've already listed the numbers in the chart. This chart makes it a little bit easier to do. So we have our x minus x bar, which is x minus the mean, and then x minus x bar quantity squared. So we're looking at finding our standard deviation using the values we've already listed and subtracting the mean from it. So this will become 2 minus 8, which equals negative 6. And 12 minus 8 will get me 4. 3 minus 8 will be negative 5. 11 minus 8 is 3. 14 minus 8 equals 6. 5 minus 8 equals negative 3. 8 minus 8 equals 0. And 9 minus 8 equals to 1. And it's okay that we get negative. And notice when I put these down in the column here, I didn't put them in numerical order, and that's okay. They can just be in the order that they're in. Now over here, what we're going to do is square each of these numbers. And when you square a number, the whole number, you're going to get a positive. So negative 6 squared will be 36. 4 squared is 16. Negative 5 squared is 25. 3 squared equals 9. 6 squared equals 36. Negative 3 squared equals 9. 0 squared equals 0. And 1 squared equals 1. Now, when I add all of these together, I get the summation, which summation is that symbol there. It means to add them all together. And I get a total of 132. So now to do my standard deviation, remember that the standard deviation is the square root of the summation of x minus x bar squared over n minus 1. So that's our formula. Well, we've already found the summation part right here. So for us, the s will be equal to the square root of 132. Our n is the number of terms we had, which is 8 minus 1. Square root of 132 divided by 7. And so this becomes 4.34. You just need a decimal and you're good. You can create the decimal in this part if you want, and then take the square root of that, or just put that all in your calculator at once. It's okay to do that. So that's how we find our mean and use that mean to find standard deviation. All right, next question. So number 7, an unfair coin is flipped. If a head turns up, you win $1. If a tail turns up, you lose $1. The probability of a head is 0.59, and the probability of a tail is 0.41. Let x be the random variable for the amount won on a single play of the game. What is the expected value of this game? All right, so this will be example 7. So the probability of winning $1 was 0.59, or the probability of a head turning up, which means we win $1. The probability of a head is 0.59, and if we get a head, we win $1. Now, if we add that to what we get if we get a tail. So if we get a tail, we lose $1, and the probability of getting a tail is 0.41. All right, when we add these together, we get 0.59 minus 0.41, which will get us 0.18. So the expected value of winning would be 0.18. All right, example 8. So for example 8, we assume that a set of test scores is normally distributed with a mean of 84. So normally distributed means we have a nice normal curve. And a standard deviation of 6. Use the 68, 95, 99.7 rule to find the percentage of scores less than 90 and the percentage of scores greater than 96. So the rule means that 68% of your data points are within one standard deviation away from the mean. 95% of your data points are within 2 standard deviations of the mean, and 99.7% of your data are within 3 standard deviations away from the mean. All right. So we have I'm going to kind of draw a number line to kind of help us. And in the middle, I'm going to put our mean and our, well, I meant to put the number down here. So we got 84 is our mean. And I need to find the other values. So to find the other values, we're going to add and subtract our standard deviation from our mean. So if I take 84 and my standard deviation is 6 and I subtract 6, I will get 78. If I subtract 6 again, I get 72. And if I subtract 6 again, I get 66. So this is one standard deviation, 2 standard deviations, and 3 standard deviations away from the mean. For the other side, if I add my standard deviation instead of subtract it, so 84 plus 6 will get me 90, plus 6 will get me 96, plus 6 will get me 102. So this is 1, 2, and 3 standard deviations away from the mean. So up here, I have my mean at 84. So my next number would be 78, and then 72, and then 66. So this is 1, 2, and 3 standard deviations away from the mean. On the other side, I will have 90, 96, and 102. And this is 1, 2, and 3 standard deviations away from the mean. Now, if you remember, we talked about this is 68% of our data. This will be 95%. And this will be 99.7% of our data. So, and always remember that half of your data is below the mean and half of the data is above the mean. So this would be 50% down here, 50% up there. And remember also that when we're talking about normal distribution, we're looking at something that's normally distributed. It has a nice even curve. All right, so our first question we were asked was 90. It asked, find the percentage of scores that are less than 90. So we're talking about less than 90. Now remember that 50% of the data lies below the mean. So we have 50% of our scores are 84 and below. And then we have to figure out the percentage right here to add to it. So for the 90 is 1 standard deviation from the mean. So that will be 68% of our data. It's within that 68% part. So if we take 68% and divide it by 2, because half of our 68% is up here, and half of our 68% is below it. That'll get us 34%. And remember, I said 50% is above the mean and 50% below. So we will take the 50% plus the 34%, and that'll get us 84%. So the answer is 84. All right, the other part said, and the percentage of scores greater than 96. So we're looking at greater than 96. Well, 96 is 95%, right? So if we have 95% happening there, so we're going to do our greater than 96. And so we're looking at 95% is where that one lands. Remember I talked about half is down here, half is up there. So if it's in the 95 percentile, then we know that there is, out of 100%, all of our data points lie in 100%, right? 100% of our data is on our entire graph and the entire total. And 95% are handled or occur in that up through 96. 72 to 96 includes 95%. So I'm going to subtract 95% out, and I'm left with 5%. So there's 5% of our data that is on the outside of 96 and outside of 77. And remember, we talked about half is down here, half is up here. So if half of the 5% is down here and half is up there, and I only want the up here part, I can take the 5% divided by 2, and we will get 2.5%. So 2.5% of the data lies above 96. All right, our next question deals with our corner points and such. So a manufacturing company makes two types of pies, apple and peach. The corner points are 0, 0, 0, 16, 20, 0, and 16, 8. Create a profit function. If the profit on an apple pie is $10 and the profit on a peach pie is $10, find how many of each type of pie should be manufactured each day to realize a maximum profit, and what is the maximum profit. All right, so this is example 9. And this one, instead of me having you solve the whole problem, I'm just giving you the corner points so you could practice on the max and min. In this case, we're doing a maximum, so we're looking for the maximum value. If we were looking for the minimum, we would look for the lowest value. So I'm going to create a chart with our XY, and we also have to create a profit function. So I'm going to list our corner points that we have, that were given to us. And then we need to create the profit function. Well, the price of each pie was $10, so the profit on the apple is 10, and apple's going to be our X, and 10 on the peach. That is our profit for that. So we've got to find the values here. So we've got to plug in each of our points. So P would be equal to 10 times 0 plus 10 times 0. Well, that'll get us 0. If we don't make any pies, we don't make any money. Our next point would be 10 times 0 plus 10 times 16. Well, that'll be 0 plus 160 gets us 160. The next one, we have the profit of 10 times 20 plus 10 times 0. Well, 10 times 20 is 200, plus 0 will get us 200. On the next one, we have the profit of 10 times 16 plus 10 times 8. Well, we actually have some values that occur here. I think I'm going to work it below. So 10 times 16 will get us 160. 10 times 8 is 80. This will get us 240. So if I'm looking at my corner point chart over here, the maximum value is 240. So that's our max. So our max profit is 240 when 16 apple pies and 8 peach pies are made. Or we could say are sold, or, you know, however you want to word that last part there. All right. All right, number 10, last problem. Woohoo! This one we're going to do a little bit more work on. So we're going to use the following system of inequalities to find the set of feasible solutions graphically for the system. Determine whether the solution region is bounded or unbounded, bounded or unbounded. Find the coordinates of each corner point. So this one we're going to have to find our corner points. And first of all, we've got to figure out how we're going to graph these lines. Now, if you recall, the x greater than 0 and y greater than 0, that just means that we're going to be in quadrant 1. We don't do a lot of work for those, but we are going to do some work for the other two equations. All right, so for example 10, the first equation we have is 3x plus y less than or equal to 9. So with that, we have to find three things: the x-intercept, the y-intercept, and a test point. So to find our x-intercept, y is set equal to 0. So 3x plus 0 equals to 9. We don't leave it as greater than or equal to. We make it an equal to because we're looking for that intercept. So 3x equals 9, divide by 3, and x will be equal to 3. So the point will be 3, 0. Our y-intercept will be x equal to 0. So that'll be 3 times 0 plus y equal to 9. Well, 3 times 0 is 0, so we're just left with y equals to 9. So it'll be 0, 9. All right. Oh, and we have to do our test. And the point we've been choosing is to test the point of 0, 0, because it's the easiest one to plug in. So we get 3 times 0 plus 0 less than or equal to 9. So now we're bringing back our less than or equal to. 3 times 0 is 0 plus 0 gets a 0 less than or 9. Less than or equal to 9, that is a true statement. So we're good there. All right, our other equation was 3x plus 2y less than or equal to 12. So we're going to do the same exact points. Find our x-intercept, y equals 0. So 3x plus 2 times 0 equal to 12. 3x equals 12. Divide by 3. X will be equal to 4. So we have the point of 4, 0. Our y-intercept, where x is equal to 0, we get 3 times 0 plus 2y equal to 12. 2y equals 12. Divide by 2. Y equals 6. So this point becomes 0, 6. And then, of course, we have to test our 0, 0 point again. So we have 3 times 0 plus 2 times 0 less than or equal to 12. Again, we get 0 on this side. Less than or equal to 12 is true. All right, so now that we have our points, we can graph. So we're going to graph our equations. I have a graph over here, and on your test you would have a graph. And we're going to use our points here to do the graphing. So the first one we're going to graph is 3, 0, and 0, 9. So that's our blue line. So 3, 0, and 0, 9. I don't usually use a straight edge, but because we're doing intersecting lines, I'm trying to use a straight edge on this. All right, and then our next line is in the black, 4, 0, and 0, 6. 4, 0, 0, 6. And hopefully we can see the difference in the colors. I think what I'll do is make this one green, even though we were using the black, so that we can see the contrast in the lines a little bit easier than if they're both dark on the video. All right. Now, we were told that on our points, they were both true. So that means they include the 0, 0. We also know that we have the lines that include our axes here. I just don't always highlight those, but understand those, that we're going to be in this quadrant 1. So that means we will only shade this area right here. We won't shade outside of that because we have these two lines that cause it to stop at this point. So, question is this bounded or unbounded? Well, this is bounded because it's bound between all of these lines. It is bounded, okay? If it shaded out from it and wasn't bounded by our x and y being greater than or equal to 0, then it would have been unbounded. Now we need to find our corner points. So we have a couple of corner points here. We have a corner point right here. We have a corner point right here. We have a corner point here, and we have one here. The first three are easy to see because they are the x and y intercept and they are at the origin right there. But this one we'll have to solve using a system of equations. All right, so let's go do our corner points. So the corner points that we know are our intercepts of 0, 6, 0, 0, and 3, 0. Those came off of the x and y intercept and the origin. Now we have to find our fourth one. And the way that we do that is figure out where do the two lines intersect. Now we can get a good idea. We are probably about 2 and 3. So 2, 3 is what I'm thinking we're going to hit. But we got to go find out for sure. So to solve for this one, we're going to have a system of equations of 3x plus y equals 9. And our other equation was 3x plus 2y equals 12. So we're using the two equations that we were given. We're going to set them equal to because we need to see where these intersect. And then we're going to figure out what we need to do. So we've talked about this in class before where I like to figure out what I'm going to do here. I have a 3x and a 3x. So if I multiply the top one by a -1, and do no change on the bottom one, on the top I would get -3x minus y equals -9, and on the bottom I have 3x plus 2y equal to 12. So now when I add these, I get the x's cancel, and I get 1y equal to 3. Now once I have the y equals, I can plug y equals 3 into either one of my equations. I'm going to choose the top one because it just becomes a 3. I don't have to multiply it by a 2. So 3x plus 3 equals 9. Subtract our 3 over. We get 3x equal to 6. Divide by 3, and we get x equals 2. So the 2 and the 3 become an ordered pair, and they also become our last corner point. Okay, so that is the last part of finding the coordinates of each corner point. So that pretty much sums up what we've been doing in class. Make sure you study and work on your review.